For questions asking you to identify aldose or ketose sugars, you already know enough from all of your work learning to recognize aldehyde and ketone functional groups. So all you do is look for the aldehyde, the carbon on the end of a chain with a double bonded oxygen, or look for a ketone, a carbon in the middle of a chain with a double bonded oxygen. So now I'll go into it a little deeper. You've got enough to solve basic problems, but going a little deeper, this is one way called a Fisher projection of representing sugars. I don't care if you know the names, but I'm going to go through and draw what it means. Every one of these points is a carbon, and got an OH and an H, both coming out, and the bonds up and down are both going back, and you've likely watched a video on this, so I'm not going to do all of it. So every one of these is a chiral center. There are other ways of representing sugars. When you put sugars in water, they typically form rings. You can find this infographic on compoundchem.com. Sir Norman Hayworth developed this way of representing sugars, where these carbons in front come out towards you, and the rest of the ring, the back half of the ring, is sticking back away, and then you can see which direction the OH groups go very easily. It shows you stereochemistry in an easy way to draw. This representation is more what a three-dimensional sugar molecule looks like, forming what's called this zigzag shape that's called a chair conformation for a ring. And it shows the stereochemistry of the different alcohol groups as well. Now, they can be a little harder to see sometimes because this one here is sticking up, but sticking up really means out and up a little bit. This one here is sticking down, and here it really is down, whereas this down one is out and down a little bit. So there are things that you lose in these projections. Like in the Fisher projection, it looks very flat. You have to imagine the stereochemistry in this. Things are right angles, doesn't match reality. But I'm going to step back now and redraw this in a way to figure out if it is an aldehyde or a ketone, an aldose or a ketose. So I'll place it to the side. And what we're going to look for in it is a carbon with, like these here, 2 bonds to oxygen. But they won't be a carbonyl to the same oxygen. So let's take a quick look. This carbon has 1 bond to oxygen. This carbon has 1. This has 1, 1, 1, 1, and a second. So this carbon here has 2 bonds to oxygen. It is on the end of a chain. So if we take this hemiacetal, split it apart here, we're going to find 2 bonds to oxygen here. This is going to become a carbonyl on the end of a chain. So I'm going to do that. Here's my carbon on the end of the chain, that is an Aldo sugar. Now I'm going to convert it to a linear structure and a Fisher projection. These two oxygen become this one oxygen after the reaction. Now this here, we want these two bonds going back. They're the up and down bonds. And this bond and the, let's draw it in with a highlighter. And the hydrogen here, they're both coming out towards me. And this down oxygen is going to be on the right. The up hydrogen is going to be on the left. Let's go to the next one. This time, the OH and H are both sticking out towards us, but the OH is on the left, the H on the right. The next one. And it takes a little understanding how 3D molecules rotate in space to get this, but you could build it and figure it out. And then I go up to here. And this oxygen becomes part of the aldehyde to this side, but that reacts with an alcohol group from this side. So we've got an OH, and we have another H. I didn't show all the H's. There's another H going down. So I've got to rotate things in my head so that this CH2 OH goes down. And this takes me a moment. Well, I know what it's going to be. Since this is a D sugar, the OH is going to be on the right. So we've redrawn this in its linear Fisher projection. Not a skill you need, but I wanted you to see how this can be done and how even in a sugar like this you can recognize there's where the aldehyde is. Now if there were another carbon off here, say a CH2OH off there, then it would be the second carbon in with two oxygen attached, and it would be a keto sugar. So you can even figure it out in different representations of the molecules.